This video is about systems of linear inequalities. So up to now we've talked about linear inequalities. And linear inequalities, if you remember, we would have a graph, we would graph a line. Sometimes that line was a dashed line, okay? And we would shade one side of the graph depending on whether there were solutions on that side or not on that side. Remember, shading is indicative of solutions to the inequality. That's what we're shading for. We're shading to find solutions to the inequality. Well, in this case, we're not looking for solutions to an inequality, but to a system of inequalities. And if you remember, solutions to a system of equations was that one point that satisfied both equations, the point of intersection. Well, with systems of inequalities, we're not going to be looking for one point anymore, right? Because with these whole shaded regions, we're going to have many, many values that are going to work for these systems of inequalities. So here's our graph. And let's look at two inequalities. Let's say we have y is greater than x plus 1, and y is less than or equal to negative 2x minus 1. The first one we start, remember we just graph these like equations to begin with. The first point is here, and the slope is just 1 over 1, which creates this line. And I'm going to not fill it in actually, I'm going to leave it dotted because this is just a greater than inequality. It's not also equal to, so remember we leave it dotted. And we check to see if 0, 0 works. So let's see, 0 greater than 0 plus 1 is 0 greater than 1? It's not. So we're going to shade the other side, okay, which is up here. So that's the side of the graph we're shading. As you can see, I'm shading it pretty darkly. All right. Okay. Now we have to do the other equation. We're in red. We start at negative 1, which is here. Let's get a smaller marker. And we go down to 1, 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1, so on and so forth. And obviously if I hadn't shaded it so dark, I could get some more points going that way, but you get the idea. Now notice this line looks like it gets close to, but it doesn't actually go over 0, 0, so we can still use 0, 0 to test. Is 0 less than or equal to negative 2 times 0 minus 1? Meaning is 0 less than or equal to negative 1? It's not. So we're actually going to be shading over here again. Okay. So notice we have three regions going on here. We've got this area over here, which isn't shaded by anything. Okay, so that's not a solution to either one of our equations. We've got this area here, which is shaded with red but not black. This area here, which is shaded with black and not red. And this area here, which is shaded by both. And this area, this last area, is actually the area we're interested in. This is our solution set. This set right in here that has the black line as one of its demarcation lines. Try to make it a little bit darker so you can see. And the red line as the other. And it's got black and it's got red going on in there. That's our solution set right there to this system of inequalities. It's not a number like our system of equations. It's a shaded area. It's a whole infinite number of values in that shaded area. These two areas are solutions to one of the two. These two areas are solutions to one of the two equations, but not both. So they don't count as a solution to the system. And obviously, this isn't a solution to anything. Okay, this is sort of like the opposite of the solution to the system. This isn't covered by either area. So that's system of inequalities. It's a lot like graphing linear inequalities, but we're graphing two on a graph, and we're interested again in this area over here. My pointer is red, so it loses on the red marker a little bit, but we're interested in this area over here where there's overlap.